Hello, good morning, good afternoon, good evening, wherever you are in the world. This is Engineer Sam Wanekhan, popularly known as Edisam. Welcome you to this channel. In this video, we'll be having a mathematics, additional mathematics, further mathematics class on logarithm. This is lesson 5 of our series on logarithm. So whether you're offering mathematics, additional mathematics, further mathematics, this class is going to be of benefit to you. This class is definitely going to be beneficial to you. So before I go on, I would like you to subscribe to this channel if you've not done so. Like the video and share it with your friends and loved ones. Okay, so we are going to commence the class right away. And in case you have any question at the end, you can actually send your question either in the comment section or you connect with me via WhatsApp, or actually you can also connect with me through my social media handles such as my WhatsApp and my Instagram account. So right now we're going to commence the class. So sorry, let's me set something.
Hello, in this video we'll be looking at how to solve logarithmic equations. This is a continuation of our logarithmic class. So, um, so we're going to solve some logarithmic equations. So the first one is going to be log 81 to base x equals to 4. Log 81 to base x equals to 4. So what is going to be x? What will be the base? So what will be the base? Okay, so what do we do? To solve this logarithmic equation, in this instance, we're looking for x, but x is not directly spelled out. X is not the subject of the equation. X is not expressed in such a way that we can easily get the answer actually. So what do? We have to first of all convert this from the logarithmic form to the index form. So in the index form, this is the base x. It's going to go and raise this 4. It's going to become the base also in the index form. So you have base x raised to power 4 equals to 81. Okay, so what next? When we're doing indices, index exponential equation, this is not an exponential equation. I told you that once you could express them in such a way, either you have the same index on the left hand side and right hand side, or the same base on the right hand side that you can solve. So we know that 81 is equals to 3 raised to power 4. That is 3 times 3 times 3 times 3, 4 times. I actually showed this. If you use factor method, 81, this is 3 in 81. This is 27. 3 in 27, 9. 3 in 9, 3. 3 in 3, 1. So 81 is actually equals to 3 times 3 times 3 times 3. That is 3 raised to power 4. 81 is equals to 3 raised to power 4. So we can actually replace 81 here with 3 raised to power 4. So equals to x raised to power 4. So you have power 4 here, power 4 here. So that means x is equals to 3. Final answer is x is equals to 3. So log of 81 to base 3 will give you 4. Okay, so try your hands on this one. If log 32 to base x is equals to 5, just try your hands on this. So I'll solve the second one. In this one, we're going to look at let me rub this off. So I said you should try your hands on this one. Log 32 to base x equals to 5. So the second one we're looking at is half log 64 to base x equals to 3. So how do we solve this? How do we solve this? So what you're going to do is that based on our rule, this half here, you can take out the half from behind the log. So it's going to be 64 raised to that half. So you can write it as log 64 raised to power half base x equals to 3. Okay. So having gotten to this stage, what do? We're going to convert this from this logarithmic form to the index form. So that will be the base here is x, so that base x will come here and raise the 3 up. So this will remain as 64 raised to power half. Okay? So you have 64 raised to power half equals to x raised to power 3. So 64 raised to power half equals to x raised to power 3. How do we proceed? There are many ways we can actually proceed. We know that 64 is same thing as 8 times 8, which is same thing as 8 raised to power 2. So replace 64 with 8 raised to power 2. Then power half x raised to power 3. 2 times half is what? 1. So you have 8 raised to power 1 equals to x raised to power 3. This is the same thing as 8. This is the same thing as 8 equals to x raised to power 3. Now 8 is equals to 2 in 8 is 4, 2 in 4 is 2, 2 in 2 is 1. So 8 is the same thing as 2 times 2 times 2. 8 is the same thing as 2 raised to power 3. That is 2 times 2 times 2. 1, 2, 3, 2s. So 8 can be replaced with 2 raised to power 3. 8 can be replaced with 2 raised to power 3. So you have 8. Okay? Sorry, this is x raised to power 3. So at this point, power 3, index 3, index 3, exponent 3, exponent 3. So you can just forget the exponent 3, 3. You just say x is equals to 2. Final answer, x is equals to 2. Final answer. Okay. So this is the first part in solving a logarithmic equation, we're going to solve more harder ones in the next lesson. Okay? Or I think we should proceed. Let's not stop here. Let's just go ahead and solve the harder ones. So, moving ahead, we have log x squared minus 2x plus 5 to base 2 equals to 2. So how do we solve this? How do we simplify this? To simplify this, we have to convert to the index form. We have to do what? Convert to the index form and go ahead and solve. So to convert to the index form, this is the base 2. In the index form, this will also be the base. So this base 2 will come here and lift up this 2. So you're going to have on the right hand side 2 raised to power 2, which actually gives you 4. So this will now be left on its own, x raised to power 2 minus 2x plus 5. That's what you have. X raised to power 2 minus 2x plus 5 equals to 4. So now, this is leading to a quadratic equation. So bring this 4 over here. You have x2 minus 2x plus 4 minus plus 5 minus 4 equals to 0. So this is simple as x2 minus 2x plus 4 minus 5 is the same as plus 1 equals to 0. So this is a quadratic equation which when you factorize you're going to have x minus 1 into x minus 1 equals 0. So at the end of the day, x is equals to 1 or x is equals to 1. So x is equals to 1 twice is the final answer. Okay, I believe you by now you know how to solve quadratic equation. That is why I didn't go into details of how I jumped from here to here. But if you have any problem, let me know so that I can help you out. If you have any problem how to go from here to here, let me know. Okay, so we'll move to another one. Log x squared plus 2x plus 2 in brackets to base 3 equals to 0. So how are you going to simplify this? Just like in the first example, to simplify this, we have to convert to the index form. So, and I've always told you that when you want to convert to the index form, what do? You raise this, convert it, take it to listen. The base in the logarithmic form will also be the base in the index form. So you take this 3 over here and it will lift up the 0. So you're going to have 3 raised to power 0. So over here, this becomes x squared plus 2x plus 2 equals to 3 raised to power 0, which is actually 1. So this is x squared plus 2x plus 2. 3 raised to power 0 is 1. That was why I wrote 1 here. So you bring the 1 to the left hand side. So you have x squared plus 2x plus 2. This, when it comes here, it becomes minus 1. It's a plus here, that's why it's becoming minus 1 here. So you have x squared plus 2x plus 2 minus 1 is plus 1 equals 0. So at the end of the day, when you simplify, this is going to become x plus 1 into x plus 1 equals to 0. So final answer is x equals to minus 1 twice. X equals to minus 1 twice. Okay? So let me look at the last one. The last one here. You have log x squared plus 15 into base 4. Log of x squared plus 15 to base 4 equals to 3. So to simplify this, just like before, you're going to convert this to the index form. So this is the base. This 4 will come here and still remain as a base. So you to lift up the 3. So you have x squared plus 15. 4 raised to the power 3 is 64. 4 plus 4 times 4 times 4 times 4. 4 times 4 times 4 times 4. 4 times 4 is 16. 6 times 4 is 64. So this is 64. X squared plus 15 equals to 64. So bring the 64. It's a plus here. It's going to become a minus there. So you have minus 64 equals to 0. So minus 64 is 49. This is minus 49. Plus 50 minus 64 is minus 49. So you have x squared minus 49 equals to 0. So how do you solve this? How do you simplify this? This is difference of 2 squared. You can actually write 49 is 7 times 7. So you can write that as 7 raised to the power 2. 49 can be written as 7 raised to the power 2. Okay? 49 can be written as 7 raised to the power 2. So this is 0. This is a difference of 2 squared. Which, when you have difference of 2 squared, this is going to become x plus 7 into x minus 7 equals to 0. So final answer is x equals to minus 7 or x equals to plus 7. Okay? You have x equals to minus 7 or x equals to plus 7. That's the final answer. So we've come to the end of our lesson today on solving a logarithmic equation. Okay, this is not the end of logarithmic equation. There are still, in further lessons, we're still going to look at more, but we're going to end the class for today. So just do your practice, look for questions and solve. If you have any issues, you can connect with me via the social media platforms. Thank you so much. So we still have more classes which we'll be looking at logarithm. So thank you so much. This is actually further mathematics, additional mathematics standard. But once you can understand further mathematics, so that means the one in maths will be easy for you to solve. So bye.
So we've actually come to the end of today's lesson. We've come to the end of today's lesson now. So in case you have any question, please, we'll be delighted to get your questions. You can drop your questions, your comments in the comment section, and If you have any, you can contact me via my WhatsApp number, which is displayed here. And also you can connect with me via my Instagram channel. I would like you to connect with me via my Instagram channel. So thank you for joining us. If you're not yet subscribed, please go ahead and subscribe. If you've not liked the video, go ahead and like the video. Thank you. Bye. And watch for the next lesson.